Hello everyone and welcome back to another KSP Let's Play by yours truly, Dan the Physics Man. Coming here with part 2 of the super epic, amazing, ambitious plan to have 3 satellites up and running all at the same time. So at the end of the last episode we got Jeb safely home and got 3, count them, 3 satellites out there in orbit and ready to do stuff. So we are going to go ahead and here's our plan. As you can see if this works. We're going to have one satellite go to the moon, one go to the second moon because the universe is cool like that, and one go out into the great beyond. Not really sure if we can make it to a planet or not, but it will still go to the beyond and out there. So here we go. We'll choose whichever satellite seems to have the... Actually, it doesn't really matter at this point, does it? Because it's almost like when we deployed our satellites, because it was a 3-parter, so they all in one direction. One went kind of to the left, one went kind of whatever, one went all the way over. So we're going to start with this one. Yeah, let's see, because we can check its stats. This one has a pretty low... All of them have pretty good periapsices, so we will just do whatever we want. Oh, this is the hype, my friends. This is when you see your plans come to fruition and be like, ah geez, ah yeah. And so we're going to... So this thing is super wonky to drive, by the way, but that's fine. So we're gonna wait until we get to our periapsis, and then we're gonna see. So this is the part where this next bit I do believe will replace like the capabilities of like a whole bunch of scientists and stuff, because we're gonna be coming at here. So we'll see. So this is whoa, go that, whoa boy. So you click this knob here and you kind of adjust it to see where. What? It's that easy? You gotta be flipping me. Okay, so I haven't played this game in a long time, and I didn't actually know about the maneuver button. Oh my god. We're going to the moon, folks. This is gonna happen. So as you can see, this is where the patch-conic simulation comes into play here. So, if this goes, as long as we burn, in the direction that it tells you, I have to move the ball to find it. We burn, okay, whoa, go back. We burn in the direction that it tells you. For the amount of time it says, you will end up there. This thing is on. Whoa, okay, no, not yet. 3, 2, 1, hit it. Yeah, so now it's gonna, assuming all goes well, this should match up with this, and we should be en route. Okay, okay, we need to follow it though. Gotta follow the dot. Whoa, what? Whoa. So not only are we going to be orbiting the moon, but it's also going to fling us out onto an interstellar orbit. What? What? Oh no! This is awesome! Holy, holy crap. Okay, whoa. Okay, yeah, so one of our satellites will do that. One of them will definitely do that. This one is going to orbit the moon, though. Oh, man, this is awesome. This is super awesome. Okay, so just backing up a little bit. I was in the middle of talking about something, and I was like, wait, what? It's that easy? So, yeah, because all you got to do is just, this doohickey, this maneuver doohickey is great. Then it'll show you exactly where you need to burn and how long and in what direction you need to burn to get to where you want to go. And I think that simulates the work of like NASA, supercomputers, and PhDs all doing their job to try and get you there. So, wow. Okay, KSP. I forgot how awesome you are. I'm sorry. Can we just left and entered a zone. Oh, because we have a contract for like, hey, what's the temperature or pressure above this zone? And we could have actually collected that, which is weird. But yeah, wow. Wow, 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 wow. But yeah, so this is where the patch conic simulation comes into play, where you notice how we follow normal orbit up until we get too close to the moon. And then it says you're now encountering the moon. It's like, wait, what? And so you'll eventually get close enough. I'll actually disengage the maneuver button, say on now 18 because you see. So when you get close enough to be within the moon's sphere of influence, quote unquote, then once we're there, then the moon's gravity takes over until we leave the moon's area of influence, quote unquote, and then we go back out. And apparently, the moon, if we let this go, the purple is what our resulting orbit will be. So it's like blue is our initial, orange is our interrupted orbit, and then purple is our resulting orbit. So the moon would, once we hit the moon, it would fling us out because of the way that gravity works, which is actually pretty awesome. And this is by the way the trick that a lot that NASA will use, because using the gravity of another body, you can fling yourself like super, super far. Like, for example, I think the Voyager 1 and Voyager 2 probes, they use the gravity of Jupiter to fling themselves out over to Pluto and stuff. Or like how we have all these Mars missions happening. Guess which planetary body they're going to fling themselves off of to get to Mars. Definitely going to be that. Because we can get, like right now, we're actually quite close to the surface, but anyway, if we get close enough, we can fling ourselves farther, because it's basically the question of your flinging is how close you get to it. Now, if you hit it, obviously you die, but if you get like super close, and since the moon has no atmosphere, you can be literal meters if you're crazy enough and get a super huge fling. Like, we're talking like, I think if I did this right, I could probably fling ourselves to Eve or Duna, which Duna, by the way, in my other save, I only ever made it to Duna. I never made it to Eve, so I'm actually very tempted to go to Eve if I can make that fling work. As that is timing. That's all about timing. Like, it's right now, it's like, since we're going to be talking to the moon around when it's at this period in its orbit, we're going to be, if we got closer, like, we kept everything the same, but we just got closer to the moon, then this would probably go far, far out there, and we'd probably be flung in the direction of Eve, actually. But we're going to do another satellite. Another satellite's going to do that. Because we'll check our fuel reserves. Yeah, we don't have much fuel left. We only have 817 meter second change. So, you see, this is our orbit right now. So if we changed it, it would be like knocking down to 1900. That would probably land us back on Kerbin, by the way. So we're not going to mess with that. So we are going to go ahead and get this underway. Oh, geez. And this takes a day. Because this universe, everything is slightly smaller. Just because otherwise, take off would take like 20 minutes. Coming out to these moons take 3 days. Like it does for our NASA guys. So we're going to go ahead and warp because... And you see that satellite's going all the way around like, wait, what? Oh, our signal's super bad. Oh, because we haven't deployed our relay. Whoopsie daisy. Yep, extend that. Yeah, now we have good signal again. So we'll actually log temperature. Temperature is impossible. Well, you have to use some special business to do that, I think. Just going to check, make sure there's no new science out here, because we are quite far. Yeah, we'll save that, because it's going to be more valuable the other way. It's going to be quite far away. And then the fact that this is... Yeah, I don't feel like doing math, but that's a lot. 13 million miles or something like that. I don't know. Someone else do that math. And we're orbiting very slow, actually. Look at that. I forgot about that. So the farther out you are, the lower your orbital speed is, because we slow down a lot out here. So with 817 meters per second, we could actually crash right back into Kerbin if we wanted to. The Earth, in this game it's Kerbin, but the Earth. So we are going to, and at this speed, look at that. We can probably turn around and see the moon. Yep, there it is. Holy crap. Ah, you can just appreciate that. And then we rotate ourselves a little bit so we make sure that our solar panels are hitting. As we run out of charge out here, we won't be able to rotate and we're dead in the water. So this stuff is all getting hit by direct sunlight. That's excellent. Yes, we're going to actually speed up just a little bit. Because we're not about to wait around for half an hour. And then we're just creeping up on the moon right now. And we're actually going to see this. I'm curious how close it needs to be visually for us to actually catch it. Okay, we're coming up on it. Yeah, when a minute passes as fast as a second. So here we go. Activating patched conics. Boop. And now we're under the gravitational influence of the moon. Kerbin be damned. And we have our first flyby of the moon. Yes. Any closer and there'd be paperwork. Ah, yes. So now we'll go ahead and do what we set out to do, which is log some temperature, fresh science, send it home, boom, boom, and boom. We learned something today. Boom, boom, and boom. Maximum learning. And then finally, look at this. And yeah, we're not retrieving this, so, because that's a thing. When you transmit science, you get a fraction of the science you would get if you took it all the way home, which is fair. You know, we only transmit 42%. That's fine. So we're just gonna let our solar panels charge up our batteries a little bit before we send it out. And yeah, this is going very well. I can't believe we have this much fuel. This is amazing. No, I'm gonna pat myself on the back for that because I made a very conservative estimate for how much fuel I would need. I decided, I'm gonna pack. I think I need this much fuel. I'm gonna pack like 5 times more than I need, and that pays off. So when you're going out to space, remember, going back to get resupplies is usually not possible. So you really want to pack everything you think you're going to need, even if you're not sure. So that's why we packed like way too many solar panels because we weren't sure. We packed all the science because we weren't sure if we needed more than one. And yeah, other things. And yes, our electrical charge should be sufficient to send this home. So we will send that home. Yep. Yeah, because we could reset the goo, but we need a scientist to do that, so there it goes. And now we have science. So we're actually going to check on our orbit. So in an hour, we'll be a decent distance to the moon. So we will go ahead and do that. So 560,000 meters away from the moon. Where is it? Oh, jeez. Hey, moon, how you doing? So now we're going to slow down in our orbit, burn retrograde, to see if we can get a little... First, we're going to get into orbit, which is going to be awesome. So we will just check. We'll do a quick check. Well, first we'll save, because, when things go well, make sure you save. I think we're going to be... We're definitely going to be in orbit, but I'm not sure what flavor of orbit it's going to be. Then we'll go back to the Space Center to check off that campaign contract and see what they want us to do next. As I call this a win for Kerbal. A win for Kerbal kind. Not quite a step, but definitely... What? Oh. We got new missions. Yeah, so now... Okay, so we can actually do this while we're out there. This is great. Yeah, so it says orbit the moon. Okay, and then come back to Kerbin from orbit of the moon. So we can't do this. We have to land our satellite to do that. So at the very least, we can get in orbit. It's like, oh yeah, buddy. And all this stuff. Hey, these guys are going to start paying big bucks as our reputation increases. Yeah, so we're going to Not worry about any of this nonsense. I just wanted to check that to make sure we could maximize our profits. We're going to go back. And remember, we have 2 other satellites. Oh, this is a good day. This is a good day. I spent a lot of time talking, but, you know, there's a lot of background that goes into any flight. A lot of planning, a lot of pain. So we should be... Yeah, we're 2 minutes away from periapsis, so this is close enough. So now we're going to ever so slowly adjust our orbit. So you see, as we get closer to the moon's surface, we are flung out farther by the gravity turn. I think it's called gravity slingshot. There's a name for it, which is awesome, but we're trying to get captured by the moon, so we're going to make our stuff very small. Get out there, and we are captured by the moon. So now we can let this thing sit, and it will stay in the moon's orbit. And we have plenty of fuel, so we can actually spend another day orbiting the moon, watching our satellites go all over the place like crazy. Because now we want to get nice and close. We want to get a better view of the surface. Because why? Because science. Quite literally. So once we're here... Now I highly doubt we have enough to land on the surface. Especially because we... if we had maybe twice the fuel, we could probably land on it. Which would be crazy, considering. But the only reason why I wouldn't want to do that is because this little module can't do much. We're actually going to see, so this little thing, CurveNet, is basically, it lets you look at whatever you're over, and it tells you if you're in different biomes or not. So right now we're just over the moon, nothing special. So we're going to rotate around to retrograde and get into a tighter orbit. I'm gonna see how tight I can get it, even if it's elliptical as hell, because I want to see this. So we're gonna go ahead and get super close. Like, we'll say I want to be screaming by the moon. So we're gonna be a mile above the moon because we're crazy. So 1.6 kilometers. Can we actually pull this off? No, because we need more control. So we'll go ahead and limit our thrusting ability to a 4% of its maximum value, so that we have way better control of our thrusting. So we're getting real close. Let's say 10 miles, because I don't want to go crazy. There might be mountains on the moon. Okay, 7. So that's roughly 9 miles, I think. No, it's more like 11 miles. No, geez. All the way around. This is like 5 miles. Okay. Now let's scream by this moon. Our satellite's been down there being like, yo, are you ready to deploy us yet? I'm like, not yet, buddy. Not yet. We're doing important things today. Meanwhile, everyone on Earth is like, wait, what? When you saw that, signal dropped because, what? Okay. We do not want to do that. Sir. Whoops. Well, now we are screaming by the surface of the moon. Look at that. Wow, we're super close. Yeah, and we definitely can't land because, look, we're screaming by at 700 meters per second, and we only have 560 meters per second of motion. But yeah, look at that. Is that not just a beautiful sight? Just screaming by. I almost want to I'm just going to sit here and look for a second because I'm just thinking. It's beautiful. Just beautiful. The Earth over there, screaming, just like if I wasn't talking and there was no music, you would just... I remember, I think astronaut Chris Hadfield said something about that. It's like a beautiful loudness as the surface of whatever you're going by, whatever you're doing screens by. So we're just going to rotate our solar panels a little bit so they have maximum sun. And we're going to collect some more science. Wow, a lot of science. That's a healthy amount of science. We'll keep track of our batteries. Oh yeah. We're going to go back home and be able to build all sorts of crazy rockets from this science. And yeah, we use this, unfortunately. We should have saved it. Yeah, just like that. We made it to the moon, fellas. Campaign mission 1. Well, there's a lot of other campaign missions that happened before, but I feel they're more tutorial. This is the first one where they're like, hey, go do this. So, yeah, we made it by. And it was awesome. Guess I'll briefly mention, I thought it was kind of crazy. You notice when we were passing over here somewhere, we lost signal because we were actually behind the moon. So it's like, ah, geez, you got zero reception because like a couple million tons of rock are between you and this receiver. So that's something to be worried about for future missions when you're trying to get out here. Because if you run out of batteries or you lose signal, this thing just becomes just a hunk of metal. Can't do anything about it. So we're going to go ahead and finish this mission off. Well, we still have many satellites launched, but we're going to finish this mission off by giving this thing an appropriate name. So because it is, I'm just going to remember this. This is for me. Mark 2. Sat 1. You know what? Yeah. And we will call it, yeah, the relay is fair. Because you can label it as other things. Like you label it a ship if you think someone's in it, a station if you want to try and build it, a probe just if it's just sitting there. I would say it's a probe actually. Because it's definitely not a rover, not a base, it's not debris, it's not a plane. You could label it anything, it doesn't really affect anything besides what it shows up in your tracking station as. But yes, we're going to call it that. And oh, we're actually going to, this is, again, something that's useful to do. This is just so I know, yep. So this is actually the way that I do it, where I just say, yeah, so it has enough fuel to do this change. Depending on where it is in orbit, it can do that. Actually, it doesn't depend. Independent. Thank you. No matter where it is in orbit, it can change by this much. So this is so I know, without having to select it, if this satellite can make any kind of changes. Because sometimes in the game, you will get a mission where it's like, hey, you know that one satellite you have up there? Do you want to move that to a different orbit? And so you can attempt to do that if you have enough fuel left. This should be plenty of fuel to let that mission come up and have it succeed. It's always nice to be given missions on things that are already deployed. I'm going to check the curve net again. So, yes, this will scan for things. You don't really see too much because we're really close. Our altitude's only, this many kilometers. But we're passing over craters and things, so that's why the altitude is changing so rapidly. Can we actually, this is a display, okay, we want to, But yeah, so now we are over the moon. And that's how you do it, folks. And so next time on Dan the Physics Man, we will focus on getting those other satellites, which are hanging out in curb orbit, ready to go to new and exciting places. Thanks for watching, and remember to like, comment, and subscribe, as you know, we on YouTube do ask of those who like this, so that I could be properly encouraged to make more. And I will catch you all on the flip side.